Math 2, Module 2, Practice Problems 2.1 to 2.7, questions number 25 through 33, the last page of the review. 25 through 30 are all about multiplying the following. Write your answer in standard form. These are multiplying two binomials. I recommend the box method. X plus 4 times x plus 3, doesn't matter which one I list on the top or the bottom, but I'm going to organize my box. X times x is x squared, x times 3 is 3x, 4 times x is 4x, 4 times 3 is 12. So when I pull it out of the box and I combine like terms, I have x squared, 3x plus 4x would give me 7x plus 12. Number 26. X plus 5 times x plus 9. X times x is x squared. X times 9 is 9x. 5 times x is 5x. 5 times 9 is 45. Combining like terms again. X squared. 5 plus 9 would be 14x. And plus 45. X minus 1 times x plus 2. X times x is x squared. X times 2 is 2x. Negative 1 times x is negative 1x. Negative 1 times times 2 is negative 2. Combining like terms. X squared, a negative 1 and a positive 2 would give me a negative 1x, or you can just write it as a positive 1x, or just plus x. And then still minus 2. 28. X minus 3 times x plus 3. X times x is x squared. Negative 3x would be negative 3 times x. Positive 3 times x is 3x. Positive 3 times negative 3 is negative 9. These actually cancel here, and I have x squared minus 9. X minus 8 times x minus 3. X times x is x squared. X times negative 8 is negative 8x. X times negative 3 is negative 3. Negative 3 times negative 8 is positive 24. Combining like terms. X squared, negative 3 and negative 8 would be a negative 11x, and plus 24. Be careful with negatives. That's probably the #1 mistake I see with students on these problems. Last one, x minus 5 times x minus 5. X times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is still negative 5x. Negative 5 times negative 5 would be positive 25. Combining the negative 5x's, I would get x squared minus 10x plus 25. 31. Factor the trinomials. Determine whether or not each expression is a perfect square. In this case, factors of 25 that sum up to 10 would be 5 and 5. So x plus 5 times x plus 5, which can be written as x plus 5 squared. So it is a perfect square. B. X squared plus 6x plus 8, so factors of 8 that sum up to 6, 2 and 4, x plus 2, x plus 4, cannot be combined and written as a perfect square, so that is not a perfect square. And then C is x squared plus 12x plus 36, so factors of 36 that add up to 12, 6 and 6. So x plus 6 times x plus 6, which is definitely a perfect square. Last couple, take the square root of the given expression 32, the square root of a quantity x plus, it's the square root of the quantity 5x plus 1 squared. A square root undoes the fact that this is being squared, so this would just become 5x plus 1. B, the square root of 9x plus 4 quantity squared. Again, the square root undoes the fact that that quantity is squared. And I just have x plus 9x plus 4. 33, the first thing I want to do is check and see if this is a perfect square. Half of 6 is 3, 3 squared is 9, so I can rewrite this as the square root of x plus 3 squared. And then once again, a square root undoes something squared. So this is just the quantity x plus 3. In B, the square root of x squared plus 4x plus 4. So half of 4 is 2, 2 squared is 4. I can rewrite this as a perfect square of x plus 2 squared. And then again, the square root undoes something squared. So this is the expression x plus 2. And then the last one in C, x squared plus 5x plus 6. I can factor this and do factors of 6 that sum up to 5. Which are 2 and 3, and I could rewrite that factored as x plus 2, x plus 3, but that's not a perfect square, so I can't take the square root at all, so this one does not simplify. And that wraps up the final problems of the review.